Okay, the nature of mathematics. Again, for our session, we will be having the nature of mathematics. Now, to begin with, let's define patterns first. Patterns and sequences. Patterns refer to usual types of procedures that can be followed. So, take note of the word pattern. Patterns are useful to predict what came before and what might come after. And the arrangement of numbers is what you call a sequence. Now, this is an example of a sequence. 3, 6, 9, 12, 15 are numbers that form a pattern, and this is what you call a sequence. 3, 6, 9, 12, 15 is what you call a sequence. And the numbers that are in the sequence is what you call terms. 3 is a term, 6 is a term, 9, 12, and 15 are terms in your sequence. Next, let's begin first with the first task. The first task in your course material talks about logic patterns. So we are now on the knowledge building part. So we have here logic patterns. What are logic patterns? Logic patterns are related to geometric patterns and number patterns that are usually part of an aptitude test. It helps you arrange the order of figures. Let's have this one. What should be the next pattern? So patterns here, you look for a pattern over what is given. What have you noticed here? Look at the circle. The circle is found over here. In our second figure, where is the circle found? It's over here now. So meaning, ang circle is moved here. What have you noticed with the rectangle? The rectangle is moved over here. This is now the new location. The arrow to the right is now moved over here. Look at the figure. And the arrow going up is now moved over there. So simply, nag-rotate atong figure. So meaning, kung ako pa ning i-rotate, where should be the circle be found in this figure? Gikan diri, gi-rotate na pud nako, gituyok. So meaning, the circle will be placed over here. The rectangle will be placed over here. The arrow going to the right will be placed over here. The arrow going down will be placed over here. So this is another pattern. This is what you call rotation. Do you get the pattern for this one? Kakuha sa pattern nga nung ing-ani ato ang figure, nga figure number 3. Okay, let's proceed to the next one. Look, examine this one. This is still rotation. So here, what happened to this figure? Ni-rotate siya dire. So nabalhin dire. Ni-rotate siya dito spikas, nabalhin dire. Nya human kini ni-rotate dito, nabalhin siya dire. Nya human gi-move na ko din ha, nabalhin na siya dire. So move down, nya move here, nanadire, move up, mao nang nanadire, move to the side. So meaning, as I answer ninyo A, B, C, or D, B will be the correct answer. Okay? So it's simply finding the pattern. Next, what about this one? What should be this figure here? Check lang ninyo, gituyok na himong X. Gituyok na himong, di ba plus ni siya, right? Na himong X, kay gituyok na to. Gituyok na siya jagbalik, na himong plus again. Human kini, this is going down, gituyok na to, na himong X. Plus X. Over here, this is plus, this is X. So what will you expect here? This should be, that should be plus. Now, unsay nabantayan ninyo sa inyong gipangkuha nga curve? Awa, kini siya from here gikuha usa ka curve. Human diri nakuha og duha. Sunod ni go down ko nakuhaan og usa ka curve. Kini siya usa na lang. So what will happen to this figure? Napay curve din ha, wala na. Okay, ang answer na nato din ha is that plus ang answer ana niya. Okay? So again, it's plus times plus. Human going down, that's plus times plus. If you will look at this one, duha, usa, duha, usa, nakuhaan taog curve. So meaning, kining atong next figure, wala na nay curve din ha. It's simply the plus symbol alone. Do you get what I mean here? Okay, let's have another one. Look at the figure. You have here a circle, a triangle, a square, and a circle. Look at this one. Ang circle gisulod sa triangle. That's the output. Ang square gisulod sa circle. That's the output. What should be the output over here? Okay, ang triangle gisulod sa square. Simple as that. Because look at the pattern. The circle gisulod sa triangle. Darang output. A square gisulod sa circle. Maunay output. Nya, diri kay square man ni. So, ang triangle isuwad na ko sa square. Ayaw sa circle. Kay dili man ni circle atong given. Square man na. Is that clear? Oh, it's simply finding patterns now. Now, this time. So, this one, katong ato ang mga figures, mautoy, that will be your task number 1. You have noticed that already, that in task number 1, you will be drawing the missing figure. Do you get how to answer task number 1? Okay, now let's proceed to task number 2, the critical thinking part. Now, let's begin first with arithmetic sequence. An arithmetic sequence is a sequence of numbers in which the difference between any two numbers or expressions is the same. Look at this example. Find the next 3 numbers or term in each pattern. Now, you have here 7, 12, 17, and 22. This is what you're gonna do. Look for a pattern. Usually, this is a number, a constant number that is added. How much is added from 7 to get 12? Plus 5. Correct. What will you add to 12 to get 17? Plus 5 gapon. What about 17 to 22? Piligi add na to, it's still 5. Or this is what you call an arithmetic sequence. Kaya nga naman, plus 5, plus 5, plus 5. Constant ang number nga gi-add. I can have plus 3, plus 3, plus 3 for that. It's still an arithmetic sequence. As long as constant ang number nga gi-add, gitawag na natog arithmetic sequence. Now, what we are asking now is to find the next 3 terms. So what will you do now? You will add. Okay, so 22 plus 5 is 27. Human, kining 27, maon na sa ni-ada na ako og 5 to get 32. Kanang 32 plus 5 na pod na. So meaning, the next 3 terms are 27, 32, and 37. So this is what you call an arithmetic sequence. Is our first example clear? Okay, let's proceed to our second example. Look at this one. Look for a pattern. What's the pattern there? Subtraction. How much is being subtracted? Minus 3. Sunod, minus 3 again. Sunod, minus 3 again. When you say minus 3, it's the same as adding negative 3. The same na siya concept. Subtracting or adding a negative number, it's totally the same. So meaning, what should be the next numbers? Ni-stop ta sa 36. What is 36 minus 3? 33. Next, 33 minus 3. 30. Next, 30 minus 3. 27. There you go. Oh, meaning, the next three terms are 33, 30, and 27. So this is what you call an arithmetic sequence. Now, we have a formula for the arithmetic sequence, and this is the formula. Let's identify the parts of the formula. A sub n is the nth term. A sub 1 is the first term. N is the term number. D is the common difference. Okay? Now, let's apply the formula in our first example. You are given 4, 7, 10, and 13. You are gonna find the 25th term. Take note of this formula. So we are looking for a sub n, and a sub n is simply a sub 25. Now, what is the first term in your sequence? When you say first term, the first number, you have the number 4. So, the first term is already given. What about n? What is the value of n? There you go. Kini siya, mauni atong n, ha? That's 25. So, okay na atong n. What about the common difference? Yes. How much? 3. Okay, we added plus 3, plus 3, plus 3. So, the common difference, another way of solving that is simply second term minus first term. So, 7 minus 4, that's 3. Oh, let's substitute everything to the formula. So, this is now a sub 25 is equal to, what is the first term? 4 plus, what is the value of n? 25 minus 1, that's a constant. What about the d here? What's the value of d? 3. Okay, next. Ato sa ning isubtract. So, 4 plus, what is 25 minus 1? 24. Now, next thing to do, multiply. What is 24 times 3? 72. What is 72 plus 4? Oh, this is now the 25th term. Mo na ni answer na to sa atong problem. Is our first problem about arithmetic clear? Claro? Okay, let's continue. Let's continue. We have here another example. So we have here, what is our formula? Our formula is this. So what's the first term? This is our first term. What is the value of n? N is 32. There you go. This one is your n. What about the value of d? Is it positive 4 or negative 4? Okay. This is now the one thing that you need to remember. Nagkagamay gani ang number ana, negative inyuhang common difference. Increasing gani inyuhang numbers, just like in our previous example, positive ang common difference. Is that clear? Okay, that's the one thing you need to consider all the time. If it's increasing, the difference is positive all the time. If it's decreasing like this one, the difference is negative. Okay, substitute everything to the formula. A sub 32 is equal to, what's the first term? 79 plus n, what's n here? 32 minus 1, the common difference. Do not forget the negative sign, negative 4. Okay, let's continue. 79 plus, this is 31 times negative 4. Now, multiply these. How much is 31 minus, times 4? 31 times 4. Negative, yes, negative 124. Okay, what is 79 plus negative 124? Take note that unlike signs, you need to subtract them. 79 minus 124 is how much? Negative how much? Negative 45. So again, using your calculator, it will give you negative 45, right? Were you able to get negative 45? 79 minus 124. It's negative 45. Oh, this is now the answer to our problem. It's simply negative 45. Are there any questions about this example? Okay, let's continue. Let's continue. This time, natay gitawag natog arithmetic series. Kanang arithmetic series, it talks about the sum na. And these are the formulas. So take note, ang pasabot aning arithmetic series kay sum of the terms. Now, we have two formulas for this. Our first formula is this. We will be using this one if the first term, the last term, and the number of terms is given. The first term is given, the last term is given, the number of terms is given, maunay gamiton. The other formula is this. When do you use this? You will be using this one if you are only given the first term, the common difference, and the number of terms. You are not given walay last term na gihatag dire. Mo ni difference ani. Ang first formula gamiton kung naay first term o last term. Ang second formula gamiton kung walay last term nga given. Anyway, we will apply, we will use the formulas in my example later. So take note of that. So we have here, the number of terms is n, a sub 1 is the first term, a sub n is the last term, d is the common difference. Now let's apply this one. 4, 7, 10, 13. And we are looking for the sum of the 15 terms. Now, here's my question. Is the last term given? Na ay 15th term, ana. Diba ang last term dapat is a sub 15. Is the last term given there? No. So we will be using this formula. Okay? So let's as now determine atong isubstitute. So we have S sub 15 is equal to pilay value ni n. Okay, this is the value of n, 15 divided by 2. Okay, then we have 2 times, what is the first term? The first term is 4. Plus, the value of n, you already know that, that's 15 minus 1. Times, what's the common difference? 3. There you go. Oh, isolve rin na to. We have, what is 15 divided by 2? 7.5. Okay, now let us solve this one. This is now, how much is this? Multiply. 8. 8. 2 times 4 is 8. Okay, what about 15 minus 1? 14 times 3. Okay, so bring down na tong 7.5. I-bring down na ko si 8. Now, what is 14 times 3? 42. Next, add 8 and 42. 50. 50 times 7.5. 370. Oh, this answers the question. Don't worry. Inyong kopyahon or i-screenshot na lang ninyo. Oh, i-screenshot. Naani siya video recording. I am recording this right now, but you can view this as many times as you want. Okay? Okay, let's continue. Okay, this time, you have noticed now, this is the last term. Kay na ako'y tuldok nya, comma 47. So I will be using the first formula. So we have S sub 11 is equal to, what's the value of N? 11. So 11 over 2. What is the value of the first term? 7. Plus the value of the last term. 47. Simple as that. So we now have, what is 11 divided by 2? 5.5, right? And then adding 7 and 47, how much is this? 54. Multiply 5.5 and 54. 297. So this is now the answer to the problem. Okay? Screenshot sa ninyo. Okay, can we now continue? Okay, next. Let's have the word problems now. Because in your problem solving, in your critical thinking, word problems man to, diba? Now, let's analyze the situation. An auditorium has 20 seats on the first row. So what is 20 seats here? The first term. Very good. So this is the first term. 20 seats, that's the first term. Take note of that. What about, this is 24 on the second row, 28 on the third row, so on and so forth. So our sequence is 20, 24, 28, so on and so forth. Now, there are 30 rows in a seat. So what is 30 here? That's not the last term. That's the value of N. Okay? Because you have 30 rows. Meaning, there will be N is equal to 30. And look at the problem. How many seats are in the 30th row? Are we looking for S or A sub 30? We are looking for A sub 30. So the problem is pila kabuok seats sa 30th row. So let's substitute everything to the formula. So this is A sub 30 is equal to, what is the first term? 20. What's the value of N? 30 minus 1. What is the common difference? Look at this one. Pili gi-add. plus 4, so positive 4. Okay, let's solve this. 20 plus, this is subtract 29. What is 29 times 4? 116. 116 plus 20. 130. Oh, mauni ang number of seats sa 30th row. Is this problem clear? Okay, so take note, 136 seats. Now, I am gonna change the question. How many seats are there in the auditorium? No. The question is, in our previous problem, their 30th row. Mauni number of seats. But the question is from row 1 until row 30th, pila man kabuok seats tanan. So, ang gipangita na ko diri is the sum now. Okay? So, gipangita naman, how many seats are there in the auditorium? So, we are looking for the sum. Okay? You get the idea? So, we are looking for S sub 30 because there are 30 rows in the auditorium. Now, what is the value of N? 30 over 2. What is the first term? 20. What is the last term? Gisolve ni nato ganiha. What was the value a while ago? Ato ibalik ha. Pili value dira? 100? Oh, you will use that over here. Plus 136. Okay, let's calculate this. This is how much? 15. Yeah, 20 plus 136. 156 times 15. Multiply 15 times 156. Yeah, it's a big number. It's a big number. That's quite a big number. Okay, 2,340. So meaning the auditorium has these number of seats. That's 2,340 seats. Is our problem clear? Claro ra? Okay, let's continue. Let's have another problem. So you have here, the university hired you as a laboratory assistant. Your starting salary, okay, so obviously, what is 41,500? What is this? Start first term. So, nanatay first term. 41,500. Each year, you will receive a raise of the amount of 1,700. What is 1,700? That's added every year. No, that's not N. D, correct. Kay mao man ni constant number nga gi-add. Ang imong sweldo kada tuig mo increase og 1,700. So meaning that is the common difference. Okay? Now, how much will you earn during the 15th year? So ang gipangita di ay nato dire is si A sub 15. Ang 15th term na nagani mga TH na 14th, 15th, 1st, 2nd, 3rd, 4th, 5th. Mao ni mga gitawag natog ing ani terms. Okay? So we will be having A sub 15 is equal to, unsay formula gamiton? This one. Or what is the first term? 41,500. What's the value of N? 15. Naaray, mo ni siya ang value sa N. Minus 1. Pili common difference. 41,007. Okay, let's compute this now. So we have 41,500. This is plus, by the way. Plus. This is how much? 14, right? What is 14 times 1,700? Again, it's 23,000. Okay. 23,800. I-add nimo sa 41,500. How much is that? Okay, there you go. In US dollars. This is the sweldo niya. Annual ha, annual. Annual salary during the 15th year as a laboratory assistant. Okay? Is this problem clear? Okay, let's continue. Now this time, geometric sequence. There is a problem there, one problem that is all about geometric sequence. Walay geometric sequence in your course material. There's no discussion on that, but I'm gonna include that in our discussion today. Okay? Now to begin with, let's define this first. A sequence of numbers in which each term is formed by multiplying the previous term by the same number of expression. So, katong arithmetic, nag-add ka or nag-minus. Sa geometric, nag-multiply ka or nag-divide. Mo ni difference nilang duha. So, let's have this one. Oh, what have you noticed here? Pilay gi-multiply nako to get the next term. Times 3. Correct. Times 3. Correct. Times 3. Correct. So, meaning, to get the next term, what is 81 times 3? That's 243. 243 times 3, that's 729. 729 times 3, that's 2,187. So, simply, the next three terms are, no, that's not 33, that is, sorry for that, sayup ni, it's simply 243, 729, and 2,187. Okay? Now let's have another example. This time, this is now dividing. Nagkagamay gani na siya, division na. So, pila may divide na ko na? How much did I divide there? Divided by 2 or simply times 1/2. Okay? Divided by 2 to get that. 128 divided by 2, that is 64. Okay? Now, what will be the next number? 64 divided by 2. Correct. 32. What will be the next number ni 32? 16. 32 divided by 16. Divided by 2 is 16. Next number. 8. Because 16 divided by 2 is 8. So the next three terms are 32, 16, and 8. Okay? Now, this is now our geometric sequence formula. If the first term of a geometric sequence a sub 1, the nth term is a sub n, the common ratio is r, this is the formula. A sub n is the nth term, a sub 1 is the first term, r is the common ratio. Ang r is simply the number you multiplied. Okay? Now, let's apply this in our next example. This is now, what is the 10th term? So, take note, we will be using this formula. And we are looking for the 10th term. What is the first term? 4. This is the first term over here. What is the value of r? Pili gi-multiply to get 8. 2, correct. I'm gonna be writing 2 there. Next, what is the value of n? 10. 10 minus 1. Okay, let's solve this. 4 times 2. What is 10 minus 1? Okay, please do not multiply 4 and 2. Unsay unahong buhaton? Kini. Use your calculator. What is 2 raised to 9? This means 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. Multiply 2 9 times by itself. How much is that? 200. How much? 256. Okay. Now, multiply 4 and 256. How much is that? 4 times 256. 1024. Oh, this is the answer to the problem. The 10th term is 1024. Okay? Can we now proceed to the next example? Okay, next example. Yes, any question by the way? Any question? Okay ra ha, okay ra. Next. The first term, oh, klaro na kaayo. The first term is 500. So, the first term is 500. The common ratio, it's given already. This is the value of R. What is the 7th term? So, we are looking for the 7th term. A sub 7. What is the first term in the problem? 500. What is the value of R? 0.2. What is the value of N? Okay. I-minus ang exponent first. So, you have 0.2 raised to 6. Now, what is 0.2 raised to 6? 0.2 times 0.2 times 0, 6 times. Pili answer 0.00064. Were you able to get this answer in your calculator? Were you able to get 0.00064? Okay. Times 500. Pili ni gawas. Okay, that is now the answer to the problem. 0.032. Are there any questions about this example? Okay, now let's have another one. For the geometric sequence, so you have there A sub 1 is 5, R is 2, and the 6th term. So we are looking for the 6th term. So this is now A sub 6. What is the first term? 5. What is the value of R? 2. What is the value of N? 6 minus 1. Okay. We have 5 times 2 raised to 5. What is 2 raised to 5? 2 times 2 times 2 times 2 times 2. 32. 32 times 5. How much? 160. And this answers the question. Okay? Okay, let's continue. Now this time, let's have a word problem. Okay? So a ball is dropped from a tower. The table shows the heights of the balls bounces. Which form a geometric sequence. So take note, nagkagamay siya. Therefore, expect this is a fraction or a decimal number. So, to get the common ratio, the formula is this. To get the common ratio, it's so simple. 150 divided by 30. What is 150 divided by 300? 150 divided by 300 is how much? 0.5. Okay, this is your R. Take note of that. And what is the first term? 300. Oh, let's solve everything now. We are looking for the sixth bound. So meaning we are solving for the sixth term. The first term is 300. What is R? 0.5. What is N? 6 minus 1. Okay, let's solve this. 300 times 0.5. You subtract these two, you will get 5. Now, what is 0.5 raised to 5? Okay, let me write that down. 300 times 0.03125. Multiply that by 300. Okay, 9.375. Oh, this answers the problem. The sixth bounds is simply, that is 9.375 centimeters. Any questions about our first word problem sa geometric sequence? Is this clear? Okay, let's proceed to this one. So this time, it's still depreciation. When you say depreciation, nagkagamay ang value. So a table shows a car's value for 3 years. Kabantay mo anang ang material, things like auto. Magkadugay siya ang presyo magagamay, right? It depreciates. Like your cell phone, you bought it karon 20,000. Probably 5 years from now or 10 years from now, mahimo nilang ng katungaan na tag 10,000 na lang na siya. That is possible. That is what you call depreciation. Okay? Let's solve R first. R is simply 8,000 divided by 10,000. How much is 8,000 divided by 10,000? 0.8. This is our R. Okay? And our first term is 10,000. Let's use the formula. This is the 10th year, the 10th number. The first term, correct? What is the value of R? What is the value of N? 10 minus 1. Okay. Let's solve this everything sa calculator. 1,000 or 10,000, 0.8 raised to 9. Use your calculator. I-times right away ni 10,000. What's the result? Gimultiply na ni mo 10,000. Multiply by 10,000. Okay, the price of the car is now 1,342.18. This is now the price of the car during the 10th year. Okay? So are there any questions about this? Are there any questions about this? By the way, this is my question. Mauna ni siya ang quite tricky. Look at the problem. table shows a car's value for 3 years after it is purchased. I will be relating this to your... Oh, that ends our part. Discard. That ends our critical thinking part. Okay? Let's go to the creating part. Let's go to the creating part. This is now the creating part. There you go. Now let's just look at this one. I would like you to reflect on this. This is now the creating part. I would like you to make a reflection on this. Does math really appear in nature? In a word, yes. However, unless you know what to look out for, it isn't very easy to spot. For example, would you have thought that the breeding of rabbits could be modeled on a simple number sequence? But this same sequence can be used to construct the spiral shape that we see on a seashell. In this presentation, I aim to show some examples of the many different cases where you can find math in the real world. Look at this one. A pretty face. It is quite obvious that the human face is symmetrical about the vertical axis down the nose. However, studies have shown that the symmetry of another person's face is a large factor in determining whether or not we find them attractive. The better the quality of the symmetry, the more mathematically perfect it is, and the more aesthetically pleasing we considered it to be. In short, the better the symmetry of someone's face, the more attractive you should find them. That's all about symmetry. Next, beehives. Kanang puy-anan sa mga buyog. A beehive is made up of many hexagons packed together. Why hexagons? Why not squares? Why not triangles? Hexagons fit most closely together without any gaps, so that they are in an ideal shape to maximize the available space. So it's just very, very makahuna-huna ka bangangat mo ka ng beehive no kay hexagon siya. And why not or triangle? Why not square? Because a hexagon fits most closely without any gaps. That's one reason. Okay, this is now the thing that we are looking for. Then this will be a part of your creating part. Rabbit multiplication. The breeding of rabbits is a very effective way of demonstrating the Fibonacci sequence. The Fibonacci sequence is a sequence of numbers formed by adding that number or altogether the two previous numbers. I'm gonna be writing down this one. I cannot. Okay, sige na lang na. So we have here 0, 0, 1, 1, 2, 3, 5, 8. The pattern is so simple. What is 0 plus 1? 1. What is 1 plus 1? 2. What is 1 plus 2? 3. 2 plus 3? 5. 3 plus 5? 8. 5 plus 8? 13. 8 plus 13? 21. 21 plus 13? Oh, this is what you call a Fibonacci sequence. And you know what? This is relevant to the rabbit's breeding. Well, let's look at this one. Let's suppose a newly born rabbit or a newly born pair of rabbits, one male and one female, are put in a field. Rabbits are able to mate at the age of 1 month, so that at the end of its second month of life, a female can produce another pair of rabbits. Suppose that our rabbits never die, and the male or the female produces one male and one female every month. What would happen? Look at what would happen. We started with one rabbit. At the end of the first month, we only have one pair gihapon. At the end of the second month, so this is our pair, narara siya dire, nanganak siya, naana say bag-o diri nga rabbit. Ang bag-o nga rabbit, mauna ni siya ang bag-o. Kini siya ang karaan ni nga rabbit. Ang karaan nga rabbit, mauni siya, nanganak na pud siya og bag-o nga pair sa rabbit. Nya, ang katong karaan natong i-focus sa ang karaan na pud, nanganak na pud sa duha, ay pair. Nya, dara siya dire. Now, going back here, look at this one. This is the newly born rabbit. So, after a month, wala pa. After 2 months, o nanganak na pud siya. O kabantay mo, 1, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 5. This is a Fibonacci sequence. And you can see that all around you. Just like example, this one. The Fibonacci sequence can also be used in another more visual way. This is the process of creating Fibonacci rectangles. We start with 1. I'm gonna add 1. So out of this, I can make a 1 plus 1, 2 na. So out of this, I can make a triangle, a square, nga 2 ang side. So nya, 2 plus 1 is how much? 2 plus 1? 3. So ang side, 3. Nanakoy square na pod nga 3 ang side. Sunod, 3 plus 2. O 5 na pod ang measurement. 5 ni siya, 5 ni siya. Now, what is 5 plus 3? 8. What is 8 plus 5? 13. And you know what? You can see that in a shell. If you will be connecting kini siya, you can see the spiral in a shell. And that what makes Fibonacci sequence very, very amazing. Okay? Do you get the idea now of the Fibonacci sequence? Now, naapot tay Fibonacci sequence sa ato ang mga flowers. The sunflowers, look at this one. Naani siya Fibonacci sequence. The number of seeds there is a Fibonacci number. And take note, if you will be getting the ratio of the two numbers in a Fibonacci sequence, the answer is what you call a phi. That's 1.618. This is often found in nature. A golden spiral formed in a manner similar to a Fibonacci spiral can be found by tracing the seeds of the sunflowers. So, kini siya na ako'y makita nga Fibonacci ana niya. Fibonacci numbers. Okay? Similarly, look at this one. On many plants, the number of petals is a Fibonacci number. Diba ang Fibonacci numbers nato kay 0, 1, 1, 2, 3, 5. Na ay number 3, na ay number 5, na ay number 8, na ay number 13. Ang petals nato sa mga plants, mga flowers, are Fibonacci numbers. Nga namang walay tanom nga ang petals 10. Nga nung wala may tanom nga ang petals 15. Nga nung ni-follow man na. That's the very nature of mathematics. You don't directly see it, pero kung imong tan-awon closely, mathematics is there. Just like what you see, the Fibonacci number. You get what I'm saying here, class? So these are the different flowers. Ang lily ug iris na 3 petals. The buttercup, the wild rose, na 5 petals. These flowers have 13 petals. Kini 21, kini 34, kini siya 55 and 89 petals. So on and so forth. Isn't that a coincidence? Right? Now, another thing, there is what you call fractals. Fractals don't appear in nature as such, but they are another clear example of way mathematics and nature can be linked. An example of this, I'm gonna just make it more precise. Ato na lang diretsyoon. So we started with this one. Kabantay mo ana, fractal ni siya. Onya kini awa. This is a fractal. Stage 1, stage 2, stage 3, stage 4. If ato nang ihumanon, di ba this is a snowflake? This is an example of a snowflake. So a snowflake has mathematics on it. Okay? Next, these are fractals again. Fractal trees, fractal ferns, fractal spiral. Now, I'm gonna be showing this to all of you. The beauty of mathematics. Here is an interesting way to look at the beauty of math. Look at this one. Look at that. If you will be solving that using your calculator, that's totally true. Even this, if I'm gonna calculate that, that's totally correct. Now, look at this symmetry. If I'm gonna multiply 1 times 1, look at the numbers. Look at the results there. Look at the outcomes over here. 1, 2, 3, 2, 1. 1, 2, 3, 4, 3, 2, 1. 1, 2, 3, 4, 5, 4, 3, 2, 1. Those are correct answers. Now look at this one. From a strictly mathematical viewpoint, what equals 100%? What does it mean to give 100%? How about achieving 100%? What equals 100% in life? Here's a little mathematical formula that might help answer this question. If A, B, C, D until Z is represented by the numbers 1 to 26, so take note, A to Z has 26 letters. So it has represented si A kay 1, B 2, C 3, so on and so forth. Then hard work ang H8, A1, if you're gonna add that, that's 98% only. If you're gonna have knowledge, 11, 14, adding all these numbers, you will get 96% only. But attitude, if you're gonna have the word attitude, and you'll be adding the numbers there, that's 100%. Therefore, one can conclude with mathematical certainty, while hard work and knowledge will get you close, attitude will get you there.